Okay, folks, we are back for the next installment of the All Things Facades podcast, and we brought back a fan favorite in Eliot Benor, who you could see on the screen. But we also had join us Ian Graham, and Ian has an incredible amount of experience, not only from the facade consulting side, but also with the Department of Buildings and being involved in the progression of writing of energy codes and how that's all impacting our existing building stock. So, Ian, I'll give you a chance to introduce yourself, but really this is the All Things Energy podcast. So with that, feel free to introduce yourself, Ian.
So introduce myself on the All Things Energy side. So as Adrian pointed out, I've got a couple of years experience, particularly in energy modeling, energy analysis. I did that in a private consulting role for about 30 years, helping buildings and code officials in the state of New York and so forth in the city of New York figure out what energy codes are going to look like, how people are going to comply with energy codes, how people are going to reduce their energy operating expenses and so forth. Then took a short stint with the New York City Department of Buildings, short-ish stint, about 3 years. Joined the local Law 97 team to try to help figure out all the parts and pieces and how that was all going to work in terms of compliance and enforcement and the technical details of the rules and the law, and have subsequently left government employment and am now back in the private sector, helping folks figure out back to energy work, so forth.
So I really want this conversation to be stemmed around the theme of Local Law 97. And I think people who are listening to this who are in many different geographies, climates, and different parts of the country. So people have heard it as a buzzword and something that's being or to be implemented in New York City. And we're seeing subsequent programs being enacted or sort of talked about in other jurisdictions. But I guess from my own knowledge too, I want to understand, where did this stem from? You had a lot of programs like LEED and initiatives to try to build healthier buildings, but this is a major, what Eliot would say, paradigm shift, where we're not necessarily following a rule book in just checking a bunch of boxes to build a healthy building. This is a true measuring tool to clarify if our buildings are actually performing to the standard that we think we're building to. So has this been a long time in the making? Or is this did this just suddenly hit the market and catch everybody by surprise?
I think it might be a little bit of each. I would say I heard a bright person I admire at one point say that, the greater buildings laws that were sort of local law 84, 85, 86, 87, 88, way back when, were sort of the precursor, right? So we know about local law 84, the benchmarking law. We know about local law 87, the commissioning, retro commissioning law, energy audit law. We also know that somebody, I think this person said that that local law 97 actually was probably the first thing everybody started thinking about when they took those first steps towards starting to regulate energy performance of buildings and starting to do a deeper dive and asking owners and property managers and so forth to start looking at what do your energy bills look like, how are you performing, or the things you could be doing to improve, right? So local law 97 was sort of maybe out there, and if you look at it now in retrospect, you can see how all those things, when implemented well, right, would have helped property owners sort of be ready for a local law 97 universe.
And before we dig deeper into that, Eliot, what would be the most elementary way of explaining to people that don't know what Local Law 97 is?
Sure. And let me just say first that a lot of other cities are using Local Law 97 as the template for their own carbon reduction laws. So even though this is a local law in New York, places like Boston, Washington, they're all looking at this law and tailoring it to meet their requirements in their cities. But they're going to look very similar in some ways.
Even though we haven't seen the effectiveness, do you think that's a premature action or step?
I don't, because they are looking at this as their first crack at everything, just as we are. I mean, there are changes being made every year by every administration, and the law will evolve, and the laws in the other cities will evolve as well, but they have to have some starting point. And I think the premise of not using engineering terms or engineering measurements, but using bills. So using quantity of energy and dollars as their metric for how to measure, which is important and gets to the question you asked, is what's it measuring? It's actually measuring all the energy coming into that address that comes from non-renewable sources. So they don't care how you lose it. They just care how you buy it, how you purchase it. And it makes it a lot easier for politicians and administrative people to write a law, enforce a law, and understand the law, rather than using U values and R values and therms and Q and all the other terms that are science-based terms, but not necessarily a good way of quantifying how much energy is used in a building. The billing is still the easiest, most effective way to see how many kilowatt hours, how many MBTUs you use. That's still a very, very effective and accurate way of charting how much energy is used in a building. One thing people get wrong is they think it's only the owner's energy use, and it's not. It's all the energy going into that address, whether it's tenant energy, owner energy, it's all the energy going in.
Yep, all the energy that crosses the property line. Just to sort of tag on to what Elliot is saying, energy codes, I like to say, were sort of like in the car world, the CAFE standards. What's your mileage, right? It was an objective metric to compare the performance of one building against the performance of another, and to set standards of operation. But every commercial we ever saying that when they talk about mileage, they say your mileage may vary, because the way we drive our vehicles varies from the standard that's used to determine your mileage for that car that's on the sticker, right?
Well, so I guess if a building owner is going to be fined based on their energy use intensity or based on that bill, where is the distinction between what a building owner is paying, hot water service, et cetera, versus what the individual tenants are paying? I guess a better way of phrasing that is, how do you incentivize the tenants to be more conscious about turning the lights off, their plug loads, leaving the shades down, and all of that?
So Ian mentioned before the previous laws that were part of the climate mobilization suite of laws. And one of those was sub-metering and master metering, right, Ian?
Yep.
And that's how, sorry, go ahead.
No, yeah, Local Law 88, which is now, again, compliance with that is right around the corner as well.
So where you may have had 15 units in a building that were all on 1 meter or all on individual meters, now there's a master and sub-meter required by law for every space.
So Ian, you spent, I was going to say many years, a few decades, on the energy modeling side. And
Yep.
So historically, from a design standpoint, and then from, call it an as-built standpoint, I guess perhaps you didn't have as much scrutiny on your work. Would you say those individuals who are still in the design community or the technical community developing those models are now way more conservative? Is there sort of a different approach on how they're approaching the envelope, given that, potentially 5 years, 10 years down the line, there could be a lot of scrutiny in what was designed versus how the building was actually built and how it's performing?
Well, over the decades of doing this, major transformations with the industry are energy code enforcement, right? So the city of New York actually turned around and started enforcing its energy code, and that transformed the way people started looking at the energy performance of buildings. That said, when most properties, when they submit, they're not running an energy model to demonstrate like energy code compliance, right? LEED, while it's an ever-growing or has been an ever-growing sort of segment of what's going on out there, it's still a relatively small fraction of the overall built environment. That said, energy models, when they are run to demonstrate compliance, and I think the new codes, which are moving towards, right, have moved toward or are moving toward a building performance standard, it really looks like energy modeling is going to become almost the default way of demonstrating compliance. I know that national labs are working on automated tools and so forth, but California's been doing this for a long time. Title 24, it's an energy model background build type of a thing, and it's important to understand, like Title 24 or any of the energy modeling standards, whether it be LEED for LEED or for any of the other green building standards that are out there. They're compliance tools, and even for energy code compliance, it's a compliance calculation. What they try to do is hold things constant between two models, and they also assume sort of perfection in certain respects. The Title 24 locks down a lot of the assumptions that are in there. So the energy performance of a building as it gets spit out from a Title 24 model is not going to be any guarantee of what your energy bill is going to look like, nor are any energy code compliance models really, because they're designed to calculate points or to show percentage improvement or to show that you've met sort of a benchmark. You're not looking for a predictive model of the building's bills when it actually goes into operation. They're looking for, is the building good enough to be built, right? So that's, and that's right. Here's my benchmark. Here's my design. As long as my benchmark is a little better than or my design is a little better than my benchmark, you're good to go, right? Or you get X amount of points. And does that make sense? I mean, I remember seeing newspaper articles like all these energy models are out there, and they're not predicting the energy performance of actual buildings, and they were never intended to, right? Number one, we know the weather changes, right? So we're using standardized weather files. That's a small change. Really, the biggest change, and I think what Local Law 97 gets at, sort of like going back to that cafe standard mileage thing, is that you're moving away from a standardized approach for reporting the performance of buildings, and you're going to show me your bills. And what's in your bills is not just how good your building could be, it's how well are you operating that building, right? And when you turn the lights on, when you turn the lights off, what the thermostat is set for, is your outside air balanced and checked? Are you over ventilating? You're under vent? Like, there's a whole series of factors that go into the actual performance of a building that the energy code doesn't even attempt to regulate. Until we start moving it maybe into these building performance standards. But it's a world. It's interesting to see where this is all going to head. But I hope that answers the question.
No, yeah, Eliot. I mean, it's kind of like I want to turn this part to you and saying that the NFRC guidelines were really developed for the residential market as a comparative tool between fenestration products, and so to now apply that to the commercial market where you have all these different sizes and configurations, and just write a code that says follow these guidelines. It's an incomplete approach, I'll call it. So do you think the current means of complying with energy code just to build a building, call it legally, that will comply, is it an incomplete means of guidelines? And do you think these new energy code revisions are going to see some of the most dramatic shifts now in how we approach buildings, because basically the old way doesn't work anymore?
So I don't like to say the old way doesn't work. The energy code was the best tool we had to do the job we were tasked to do. And you couldn't expect, we didn't have, I gave a presentation a couple of months back, and people forget, we didn't have an energy code 30 years ago. 30 years may seem like a long time to some people. It's not to the guys on this call with gray hair. We remember when there was no energy code. And then when there was, in New York, the New York State Energy Code, which was very, very light, let's call it, right? So we've been trying to catch up to things that basically started after the oil embargo in the 70s, right? Energy became expensive, and the federal government felt that it was important for us to conserve energy and be efficient. And that's where all the programs, all the energy codes came out of that, right? It was really driven by money at that point. And over the last 40 and 50 years, our paradigm changed, and we wanted to also look at how we affecting the planet we live on, and how can energy codes and building more energy efficient buildings not only affect your pocketbook, but affect the planet we live on. And that's a major factor today in how people look at energy codes. Now, in my opinion, if you really build a code compliant building, and I mean the finished product has to be correct as designed, you're building a good building. You really are. You're not building a bad building if you build a code compliant building. But Ian keeps mentioning operation, and that's the key. I have 2 monitors on my desk. I have a heater under my desk because my feet get cold. There's all these factors in office buildings, the 80-inch TV that gets left on all night long in a house. These are operational factors that have nothing to do with the way you built the building, what kind of heat pump you bought. These are how you actually operate and run your house, your office, your institutional building. This is what's going to be required in the future. It's more than just insulating your walls and putting low E on your windows. It's people have to understand what the impact is of not looking at energy. And that's a big one. That is a big one. And it's going to require training, not just from the people who run the buildings, but from the federal government. When I was a kid, everywhere you looked at, when I went to school, Ian will tell you this too, there were signs up on every light switch in every classroom when we were kids that said, turn it off. And TV commercials all the time about shutting off lights, not running hot water, not running water, period. That doesn't really exist anymore. We think it's in people's consciousness, but I could tell you that the average Prius is doing 90 down the highway, not 60, which is where it's most efficient. And that's the problem. People think I have a very efficient heat pump in my building. It doesn't matter if I run the heat at 85 all day or the air conditioner at 65 all summer. Put on the sweater. It's simple as that. Put on the sweater.
So this is the solution isn't necessarily to implement all kinds of automated building controls that sort of takes it out of the human element. It's more so creating
It's part of it for sure, but it's not the end.
It's a composite of parts, right? I mean, like Adrian, you pointed out, right? Like the NFRC rating for a window, that assumes that there's like no thermal conduction between the window frame to the substructure that it's attached to, right? When you do that rating, right? So we all know it's a false number. And we also know that if you don't properly detail that wall, right, you can have the best window in the world, but you can circumvent the performance of that window with bad connection details, right? Where you've got thermal short circuits from you got that beautiful big piece of plastic in the middle of your frame for that thermal, insulated frame. And then suddenly the substructure is a piece of metal that bridges, and you screw both to one another, and heat goes in the front of the frame through the screw into the steel stud, out, around, and right out the building. And you've completely now invalidated the actual performance or the rated performance of that building in reality, right? And there's a million places where that happens, leaving the lights on, a dripping faucet, thermostat set points, which are not, control systems, which are not properly set up to turn things up and down, to shut things off on the weekends, to do so forth, right? Like, and the most sophisticated property owners, they track their energy bills. They look at what their performance is. They're always tuning and retuning. That's why they're doing pretty well financially, right? Because they're paying attention, because they know if you take care of the pennies, the dollars will take care of themselves, right? That it's the composite of all these things, and getting people into those good habits from the top of the organization all the way down. But there's too many folks that are out there that that those mid-sized buildings where they don't have the staff to do that. They're lucky if the janitor is the guy that's going to be their HVAC contractor, right? Like so you end up with potentially underqualified people looking at these buildings, right? Property owners just trying to get by. As long as the rent is covering the whole nut, and they're happy with their income, the energy bill is a component of what's in there. And yes, they can fine tune it, but all that stuff requires investment and money. And it's easier to take money out of a building than it is to put it back in, right? It's hard.
I think you'll get a kick out of this. I want to stay on the window thing for 1 second. Obviously, Eliot, the receptors are not counted in the NFRC calculation, which is insane that you have a whole perimeter aluminum frame, which is just completely disregarded. But also, I read recently that as long as you have an adequate gap between the pane of glass and the mutton in between the glass, then they're disregarded as well, or excluded from NFRC calculation. So all of a sudden you have all kinds of grids within your glass, but it's just disregarded. So do you think we're going to get to the point where, in order for an owner to achieve TCO, there's going to be some form of auditing or monitoring, or somebody's going to come around on site and do some type of heat flux measurement or something to verify what's being built on site?
I think that's going to be part of commissioning, and people are hearing a lot more about commissioning these days. And I think that we will, and there's other technologies out there. There's a group we know in the UK that goes into buildings and retro commissions by running the heat up to a certain temperature, maintaining a temperature in the house with no one in it, and measuring how much electric actually it takes to maintain that temperature. And they can back that into a fabric, meaning the enclosure of the building performance number, which is based on an actual measurement and verifying whether or not the house was built right, or baselining for future upgrades to the envelope. We need more of that innovative technology. Some of it's simple. I mean, when I described it, it sounds pretty basic, right? You're using the home's heating and cooling system to baseline its performance. But these guys thought of it and developed a process that's traceable, accurate, and it works. And we need more of that. And yes, measurement and verification is going to be a big part of it. It doesn't mean you have to actually measure heat flux. Some of it is just about making sure that the air barrier is installed right, having eyes on everything as the building is being constructed. Existing buildings are tougher. Obviously, it's hard to see what's behind existing walls. It's very expensive. You run into contaminated materials. So there we need to have more technology to sort of baseline where we're at on existing buildings for retro commissioning. But every building that's being built now, quality is key. If you build it well, it's going to perform better. It's going to perform closer to what was modeled and what was designed. We all know that our value of insulation is not consistent, and it's a even U values, you mentioned U values, they aren't U values, they're U factors. It's another rating system. But we didn't have anything before that to use. So saying good, better, best, or A, B, C, D, or U.40, it still gives the designer and the owner an idea that this one is better than that one when installed correctly. People's knowledge of parts and pieces, as important as it is, you're right, it doesn't account for all that, but it is getting us one step closer to an overall better way to build.
So when Eliot first came out, we talked a lot about air infiltration and preventing it, and what it actually means, not only for energy, but also the risk of mold growth and discomfort and whistling and so forth. What type of impact does, if we forget about the windows for 1 second and focus on the opaque wall, stuff like thermal bridging and not actually achieving the U factor or effective R value that you designed for in the opaque area, what type of actual impact does that have on the envelope? And a lot of it, frankly, because you can't see it, people just kind of disregard it. But is it really moving the needle that much?
Yeah, I mean, it depends, right? Like it's okay. So let's just simple example, right? The steel, if you in the old days, people built with wood studs, right? And now people don't build with wood studs as much. In commercial construction, particularly, you're looking really at steel studs. Well, the thermal performance, right? Like there's still a loss. So every time you do heat through the stud, it's a little more conductive than the R value, than that nice fluffy insulation between the studs. People are like, okay, what's the big deal? Well, when you use steel studs, you cut the effective performance, right, of that insulation basically in half, right, to make it simple, right? And so it can have a very large impact, right? So understanding those fundamentals of heat transfer, right, on the designer side is critical, right? And then, like as I was describing, it's chasing all these little pieces of the puzzle. So if you understand these things, you know how to detail the basic walls, okay, then what ends up happening is it all becomes the junctions. Where does one system meet another system? Those are the points of failure, right? Because people have to pay attention. It's where the window meets the wall. You can have infiltration problems, right? You can have thermal bridging problems where steel structure passes through insulation layers. Like hunks of steel, they like to conduct heat, right? They get cold. If you're dealing with, even in our New York climate, even in unhumidified buildings, right? You have, like you can have, I've seen plenty of projects, right? And we all know of these big famous projects where you've got exterior steel structure. You have structural members piercing your thermal envelope, connecting to a piece of steel outside, which is sitting there in the middle of January and February, right? Getting ice cold. And that cold essentially, or the heat, that steel is getting cold inside. Well, humidity, like we all know, that glass of lemonade is gonna sweat in the middle of July. Well, that steel is gonna sweat in the middle of January and February if we're not careful. And now you've got a source of moisture collection, right? It can freeze there, which can cause problems. It can drip in there and start causing mold problems, right? And in fact, I was on a project once where we got a phone call from a developer because they had condominium owners in a building where literally the windows themselves were sweating so much on the inside of the space, exposed, that there was literally puddles of water on the sills. And if it was cold enough, there was just layers of ice, not like frost, not like a little bit. I'm not talking about what I used to see when I was a kid in the windows in my bedroom, where like those single pane windows, like if it got humid enough and cold enough, you get a little bit of frost in the morning window. We're talking a puddle of water, a sheet of ice on the window, right? That, number one, could have been a window problem. But that's also a ventilation problem potentially. That's interior humidity not finding its way out. And as our buildings, as Eliot talks about, right, as we tighten up our buildings, we change the interior climate of these buildings. We make all these other elements that much more critical to get right, right? And understanding how to properly manage moisture inside of buildings to effectively ventilate it and get it out, I think, right, ultimately that turned out to be a ventilation problem more so than a window problem. The windows didn't help. They were probably underperforming from what was specified, but that all gets back to, you got to make sure that someone who's watching the store, when they're buying, look, the designer can spec it, the contractor is going to try to VE it, right? An owner is going to decide that they save a couple of bucks on the window. The performance goes down, the window gets installed, right? And now it's not going to be the same building that you thought you designed way back when. So this whole idea of envelope commissioning, this whole idea of construction responsibility, because in the world of Local Law 97, ultimately your building, depending on the type of building it is going to get a limit. And if you generate more emissions on your actual bills than that limit allows, you're going to be facing penalties. And owners are going to be facing fines that they're going to have to pay, right? And guess what owners are going to want to do? They're going to want to find out who was responsible. Is it them? Is it their operator? Was it the contractor? Was it the designer? Was the building fundamentally flawed in its design? Or was it flawed in its execution of construction? Or is it flawed in its execution of operation, right? And then, so ACEC has actually put out a draft to try to identify the responsibility, at least between owners and designers, and sort of how to manage that risk as we move into this new world. Anyway, I'm going on
So
and on.
no, it's a good point, because I've had this conversation with Eliot before, that since we have a real engineer on the call, we can pick his brain on this.
I think you got a PE after your name too, Adrian.
Yeah, but you might be more qualified to answer this. So the engineering world, especially when it comes to structural loads, we build in a factor of safety. So real load's going to be 100. You might actually have a ultimate load of 150 as a design max capacity or whatever it is. So do you see designers becoming more conservative and building in a factor of safety when it comes to energy performance, given the assumption that we're going to lose energy loss through this thermal bridging or various means of the envelope?
They can't anymore. They're not allowed to. The code, prescriptive code, and even the design code doesn't allow them to anymore. Where we used to over-design everything, you're limited now. Even on the pumps that circulate water, there's limits on the horsepower of a pump now. Forget about tons of cooling, heat pump tonnage. They're not allowed to. It would be great if they could, but we've seen so many buildings in the past 4 to 5 years that are high-end, high-tech university and hospital buildings where they literally cannot heat and cool the spaces sufficiently because, the assumptions on the envelope is mostly what's killing them. But the assumptions on the envelope, designing to a very small margin of error on what they think that UNR value is, has led to, the systems being undersized, not theoretically, but in practice, the systems can't keep up with the losses, or the loads, I should say. It's not just the losses through the envelope, but the loads that are imposed upon them. In the old days, it was simple. Everyone used 30, 40% or more oversizing of their units. Today, they're not allowed to.
Yeah, and the reason, right, like, and Elliot's 100% right? Like a multitude of sins in the past were covered by excess capacity, right? The challenge, though, is that not every building underperforms its envelope the way everybody thinks it is, right? So what ends up happening is where one building needs that 30, 40% oversizing, another building really only needed 10. And the challenge then becomes that equipment, right, which is now much bigger than it needs to be in reality, now short cycles, right? It doesn't operate as effectively and efficiently, right? So that's the reasoning behind why the oversizing limitations have crept into the codes, because they realize that, like, a pump which is way oversized, I mean, in the old days it was horrible, right? That, like, literally they had something called a triple duty valve, that you'd install a pump, the engineer would guess at a static pressure, they put it in there. If that static pressure wasn't anywhere close to that, they would literally just turn a valve to create the pressure they needed in the system to get where that pump was thinking it was supposed to be. They basically created false load in a building. Now, in the world of variable speed drives, that diminishes, right? But if it's still way oversized, that drive can only start to throttle things down so much. So proper sizing, proper pump calculations, and so forth are all part of it. I mean, if you look at the new energy codes, actually the last code cycle started requiring, right, that you identify those thermal bridges in an envelope, right? And you didn't have to do anything about them. You just had to say where they were. The idea, again, make people aware of the fact that this actually exists, so they start to become aware of the fact that there's something that they maybe should be thinking about. Now, as they're moving into,
what does that mean? Identify where they were, but you don't have to do anything about it?
it was literally a code that says, tell us where the thermal bridges are, right? You don't have to do new math to figure out what it's all about. Actually, I think there was some thermal bridging calculation estimates in there for curtain wall construction and so forth. But really, they wanted to know where the thermal bridges were within the system. So that people started realizing there's a lot more than you think. These are the places you have to start considering what's going on. The idea, I think, really being, if you make a designer aware of where the issues are, they're going to start to proactively look at solutions that may impact it. Because you can't say, well, I didn't know. It's like, of course you knew. You put it on your drawings, right? Like that. But now, as they're moving forward, right now, thermal bridging calculations are going to be in the next version of the code, right? Like, so there's that whole idea of fine tuning these calculations, not just going, well, we know the wall's going to be much worse. We need to do a better job of calculating what the performance of all the different systems are, so we can end up with a properly sized system, right? The old days of just tack on some extra capacity, the code doesn't let us do anymore. So now we actually sharpen the pencil, do the math, figure out what the thermal performance are. And, and maybe during construction, you're going to start seeing infrared, thermal imaging cameras looking at where there are going to be problems, right? So they can proactively start fixing them before they get done. Or doing the, that testing you're talking about for residential has been around since I was doing residential consulting a gajillion years ago with one of the first companies I worked for, right? But it's an incredible tool. It works really well for buildings that are pretty much heating load dominated, and they're, cooling costs. Residential works well. It gets way more complicated when you start trying to extrapolate that to high rise buildings. But there are concepts, that are similar. There are other tools that we can bring to bear to inform our designs and check the actual performance of buildings before they're finally done.
Well, if you can't oversize a mechanical system, then you would think that you're going to start with your envelope and then size the mechanical system accordingly, depending on the demand or loads. How effective do you think something like an envelope backstop becomes when you dictate that anyone can only perform a certain percentage worse than code?
Yeah, so the envelope backstop is I was around when that got introduced into the code, and the idea behind it is that the best window wall system, or the best window system, or the best curtain wall system typically doesn't perform as well as the best opaque, or is even like a mediocre opaque wall. So as a consequence, the idea that glass buildings, and I think de Blasio said it, which I think was more bluster than reality, said we're ending the world of glass buildings in New York City, which they didn't. But at the end of the day, it was recognizing that putting more and more and more glass into buildings isn't necessarily going to be helping buildings have lower bills, right? You can meet the code with all glass buildings, but that doesn't mean those buildings are as good as they could be if they were more thoughtfully designed with better detailing. I mean, I remember on a federal project where the budget really drove the design more so than anything else, because they didn't have the money to put an all glass building in. I said, look, there's two things you have to think about when you're doing energy efficient design. You got to treat your windows and your lights, the lighting in your building, like they're gold, and you need to spend them wisely, right? You need to put those things into buildings in a thoughtful way. Take advantage of what's there. It's not just one size fits all. You go into buildings and they have that floor to ceiling glass. It looks beautiful. It rents great. People thinks it's super sexy. It does manage where you're going to put furniture, because if you're going to put all the cubicles and the desks right up against the glass, guess what's going to be in the first 30 inches of that glass anyway? A bunch of backs of furniture, right? So it looks great when the room's empty, but is it really effectively going to be there? I mean, there's a lot that goes into all those things, but it's anyway. I think I understand the economics of why people choose all glass curtain walls and like the minimum spandrel and so forth, because any extra element in the wall system just costs more money.
How much has some of those benchmarking tools in the local law that makes you measure the performance of the building and put the grade in the lobby? How much is that exposed in terms of how some of these higher performing fenestration systems actually perform in real time? And has anything been extrapolated from that exercise?
You want to take a stab at it, Eliot, or you want me? I would say that, look, a building is a composite of a bunch of systems that all work in concert with one another in a dance, right? And can you lay the energy bill at the feet only of the envelope system? No, right? Can you overcome, like, again, I was an energy modeler, right? And I've done plenty of energy code compliance models where we've had envelope systems which consume quite a bit of energy. That means all of the other systems have to step up their game to overcome that performance deficit, right? So as a consequence, the HVAC systems are bolstered. In the old days, people were putting cogen systems in because energy code compliance was on a dollar cost operating cost basis, right? But Local Law 97 is now saying, I don't care how much you spend on your energy bill. I want to know what you're using to heat and cool your building, right? And each of those has a CO2 impact, right? That's a new world order, right? Local Law 97 really was the first time that everyone really stepped back and they recognized we have to stop burning things, right? Because we can't afford to do it anymore and still be able to live on our planet, right? That has to end. So up until then, we thought, okay, as long as it's a relatively clean fuel, we can live with it. That's why people were moving away from oil, right? And they were moving into natural gas. We realized natural gas is better than oil in terms of carbon emissions and pollution and so forth, but it's still contributing to the problem, right? So we're in a new world order. And as a consequence, those tools that people were using to demonstrate code compliance, they're starting to go away, right? Or you can do it for code compliance if you're doing it on a dollar cost basis, but you're still going to end up with a local law 97 impact that you have to investigate down the road. So there's a lot more coming into the calculus these days to figure out how buildings need to be designed and built and operated. And I know we're concentrating a lot on new construction and design of new buildings, but I think just to point out that the existing building market is huge. The simple paradigm out there is that 80% of the buildings that are going to exist in 2050 exist today. So while new construction is important and it drives innovation and it drives people looking at things and it educates the design force and the construction force and everybody else in the process in terms of how we're going to look at retrofit of existing buildings, the retrofit of those existing buildings is critical to our success. And we got to figure out, and they require different solutions and they require different investments. So
Absolutely.
tightening up the envelope. What's that?
It's not all bad news because there's
No.
programs out there to help people with existing buildings tackle these changes. The weakness right now is practitioners to do the work. I think that's where I'm on a local law 97 task force for job development. That's
the implementation
really,
working group.
yep.
Good
And
for you.
I think that's really critical because people don't realize how deep this will affect the economy. I mean, yes, I understand building owners' fear of what's coming, but you talk about a backstop. The government put backstops in place a decade ago, started putting tools into place for financing these things at low interest. Grants, our utility companies have finally started giving back some of that money that's been on your electric bill for the last 100 years. That $6 charge for this and the $8 charge for that. The Public Service Commission finally started pushing National Grid here in New York and Con Ed to start giving back some of that money. They need to do a lot of work on their programs to get them user friendly, but they're there and we started. And there's other places, NYSERDA in New York, I think the public utilities are going to be the big ones across the country because they've been collecting money from their clients, their customers for decades and putting it into these funds that are sitting there collecting interest. It's in the billions, not the millions, of how much money is there for this. We just have to figure out how we're going to do it, and we just have to train people to do it. We still don't get blower door tests today. We still are getting people who balk at doing a blower door test on an existing building. Just like you pay someone to go in and do a home inspection when you buy a home, part of that home inspection should be an energy inspection, and a blower door test should be a huge part of that. Because if it's done right, that person can identify areas of weakness where even a single family homeowner can look at and say, I need to caulk this, I need to insulate that, I need to look at the sill plates at the foundation of my house, they're leaking air through there. That's on a small scale. On a larger scale, as Ian said, big buildings are much more difficult to do. But thankfully for big buildings that were built within the last 60, 70 years, they're very consistent, right? You don't have a lot of ornate facade elements to them, except at the top and bottom of the building. But everything in the middle is consistent, more or less. We built a lot of brick buildings in the 80s, 90s, and early 2000s that had punched openings in them. We built a lot of all glass buildings in the last 20 years, 25 years, that although they're not easy to tackle, at least they're manageable because we have consistency and uniformness in the building envelope. Now, that being said, we're in the envelope business and we think the envelope is the end of it. It's not. It's a part of it for sure. It doesn't get people past 2050. It might get them past 2040, 2035. The envelope's not everything. Neither is the mechanical system. I keep going back to its operator error.
Yeah.
And people have to start looking at what Ian said, they have to look at the light and the glazing in a building as a commodity that they should use wisely. We have to start looking at all the energy we use in buildings as a commodity, an expensive commodity, which it will become more expensive now. This law is just doing that. It's making us pay what people in Europe already pay for their electric, their gas, everything else. We just have gotten used to being subsidized with cheap energy. This law actually just levels the playing field and saying, you know what? You may be able to buy it for this much a therm, but we're gonna stop that. We're gonna claw back some of that artificially low pricing for energy, and you're going to start paying your share of what it costs us to recover from it. And I hope that's where the money's going to go. Honestly, I know we've been saying for years the purpose of the law is not to give people fines, but inevitably people are going to get fines. And I hope that some of that money goes to training the practitioners that need to do the work, doing the research we need to do. I have a great anecdotal story about ladybugs in our office at the farm, where in the fall, somebody left the door open overnight and about 1,000 ladybugs got into the office. You could see them when I came in, lined up in straight lines on the rafters in the ceiling where the heat was. Though it was amazing. It's amazing. It was like thermal imaging with live animals. That's what it was like. They just lined up at the warm and cold spots on the ceiling. It was incredible. Incredible.
Have you built that into your testing protocols now? You show up with a bucket full of ladybugs, leave them overnight, and see where they go.
I gotta tell you, that would take off.
They have a union. I'm negotiating with the ladybug union right now.
That's funny.
All right, guys, this was awesome. I have a ton of questions, but I realize it's going to spark the next hour of conversation. So I'm going to cut us off here for part one. We are going to do a part two. So anybody listening, feel free to share questions, things you want to know more from Ian and Eliot. This is a very nuanced topic, but something we're going to do an ongoing series just to continue to talk and share our insights and findings over time. So Eliot and Ian, I really appreciate both of you having on.
Thank you so much, Adrian.
Thank you, Adrian, for letting us share. Talk to you later, guys.
Thank you.